Hello students, welcome to video lecturing class for subject dynamics of machines. So today we will start with the second module, that is balancing of rotating masses, the first bit in that module. So here first we need to understand why the balancing is necessary. Okay. So the high speed of engines on the machine is common phenomenon nowadays because the machines all are designed for the high speed. So it is therefore very essential that all the rotating and reciprocating parts should be completely balanced as far as possible. Otherwise, if these parts are not perfectly or properly balanced, the dynamic forces are set up. And these forces not only increase the load on the bearing and stresses in various members, but also produce unpleasant and even dangerous vibrations. So these are harmful to life as well as to the performance of the machine. That is the reason why the perfect balancing is required. So there are two types of balancing, static balancing and dynamic balancing. So in static balance will be produced if sum of moments of weights about the axis of rotation is 0, or you can say a system of rotating masses is said to be in static balance if the combined mass center of the system lies on axis of rotation. That is, the rotor is said to be statically balanced if the vector sum of centrifugal forces is equal to 0. In case of dynamic, if a system of rotating masses is in a dynamic balance, when there does not exist any resultant centrifugal force as well as resultant couple. So for dynamic force, the first condition is the sum of centrifugal force must be equal to 0, and the second one is the sum of couple must be equal to 0. In that first one, the balancing of single revolving mass in the same plane. So let us consider a shaft rotating between two bearings, and the shaft is perfectly machined, that is no eccentricity. Hence the system is a balanced one. Now if you are going to attach a mass to the system will get disturbed there, that is the unbalanced condition will occur. So in order to balance this system, attach one more mass, that is B, diagonally opposite to that of the mass M. This mass will also produce a centrifugal force. If these two centrifugal forces are equal and opposite, then the system is said to be balanced. That is, this is the mass M and this is the attached mass B for the balancing. Because of this mass M, attached mass, the system will be unbalanced. When you attach this B at a required or at a proper radius, that time you can say that the system is completely balanced. Now moving further, the centrifugal force due to attached mass M is given by M equal to, so it is centrifugal force equal to M into omega square into R, and the centrifugal force due to mass B is B into omega square into B. Now for perfect balancing, the magnitude of these forces should be equal and their direction should be opposite. So for a perfect balancing, the centrifugal force due to mass M and the centrifugal force due to mass B should be equal and their direction should be opposite. That is, M into R should be equal to B into B. So based on this, we will come to know what will be the radius of rotation for that balanced mass, B, attached mass. Okay. So from this we can say that the less weight, more radius is preferable. Now moving further, balancing of single revolving mass in two different planes. Okay. So again, in that there are two cases. The first case is both the masses are on the same side, that is the masses are going to rotate at the same side. Let us consider a shaft rotating between two bearings, and the shaft is perfectly machined, that is there is no eccentricity. If the mass m is attached to the shaft, then the system will be disturbed. In order to balance the system, assume two balancing masses, that is BL and BM, introduced in two different planes L and M respectively. If the balancing masses are placed in different planes, then minimum two balancing masses are required to balance the system, as in addition to the centrifugal force. The couples also has to be balanced. So here these are the attached masses for the balancing of this mass M. This is M, and they are the two different planes L and M. Okay. For perfect balancing, the sum of centrifugal force must be equal to 0, and sum of the couples about any plane must be equal to 0. So here we will define some terms. That M will be the, here M is there, M will be the disturbing mass, BL is the balancing mass in plane L, BM is balancing mass in plane M, R is the radius of rotation for mass M, and BL is radius of rotation for BL, and small b suffix M is radius of rotation for BM, and this L is distance between the planes A and L, this distance between these two planes, and M is distance between the planes L and M. Now, the magnitude and position of the balancing mass can be derived by using the conditions, that is centrifugal force, that is sum of centrifugal force equal to 0 and sum of couples must be equal to 0. Hence, we need to equate the sum of the centrifugal force to 0. So there are three centrifugal forces because they are attached to three masses. So the centrifugal force due to mass M is M into omega square into R. Likewise for BL and BM it is BL into omega square into BL plus BM into omega square into BM will be equal to 0. And here omega square is common everywhere, so cancel that omega square, left with M into R plus Bm into Bm is equal to Bl into L. Now take the couples about point P, that is taking the couple about this point P, can write the couples as M into omega square into R into L, this is the force and this is the distance, which should be equal to Bm into omega square into Bm into D. We take the couple about this point P, but write the couple about due to this mass M and this mass Bm. To simplify that, Bm should be equal to M into R into L divided by Bm into D. Similarly, if you take the couples about Q, that time it is M into omega square into R into M equal to BL into omega square into BL into D, and BL can be given by M into R into M divided by BL into D. Now the second case is masses are on either side. So in the first case, these two balancing masses are on the same side of the attached mass. Second case is on either side. This is the attached mass and these two are the balancing masses which are attached on both the side of the mass M. So for perfect balancing, again it is the same condition, that is summation of centrifugal force should be equal to 0 and the summation of couples should be equal to 0. In the equation, m into omega square into r minus bl into omega square into bl minus bm into omega square into bm should be equal to 0. Here we have taken negative sign for these two because they are on different side or the direction is opposite. But in the first case we have taken only for bl because that was in the other plane. That is the reason I have taken that force in opposite direction. So mr equal to dl into dl plus bm into bm. Now taking the couple about this point P, m into omega square into r into l would be equal to bm into omega square into bm into d. When you are taking the couple about this point P, you have to ignore this bl. When you are taking couple about this point Q, you have to ignore this bm. So when you simplify that, the bm will be given, bm is given by m into r into m divided by bm into d. When you take the couple about Q, it is m into omega square into r into m, which is equal to bl into omega square into bl into d. From that you will get the value of bl as m into r into m divided by bl into d. Now moving further, balancing of several masses in the same plane. So let us consider a shaft carrying 4 revolving masses m1, m2, m3 and m4 and are revolving in the same plane, and let their r1, r2, r3 and r4 be the radius of rotation of masses m1, m2, m3, m4 respectively. Let alpha, beta, gamma be the angular position of the masses m2, m3, m4 from m1 respectively, and they are measured in the same sense, that is, they are measured in the same direction. For perfect balancing, the balancing force must be equal and opposite to that of resultant unbalanced force. So here, to get the balancing force or to know the mass of the balancing body, there are two methods. One is analytical method and another is graphical method. In analytical method, the magnitude and position of the balancing mass can be found by using this space diagram. That is, resolve the centrifugal forces horizontally and vertically and find the sum of all horizontal and vertical forces. If you resolve the forces horizontally, you get m1 into r1 cos of 0 because this m1 is along the plane, plus m2 into r2 into cos of alpha, plus m3 into r3 into cos of beta, plus m4 into r4 into cos of gamma. Similarly, for the vertical forces, it is with sine angle. Then the resultant unbalanced force is given by the square root of fx square plus fv square. So for perfect balancing, to equate b into b, that is, this is going to be the balancing mass and this is the radius of rotation for that mass, should be equal to resultant unbalanced force. So from this you will come to know the magnitude of this balancing mass. If theta is the angle which the resultant force makes with the horizontal, then theta can be given by theta equal to tan inverse of fv by fh. Therefore, position of balancing must be theta b equal to 180 degree plus theta, where theta is tan inverse of fv by fh. The second method is graphical method, and this is the most popular and simple method which is we are going to follow to solve the problems further. So first you need to construct the tabular column. So for that is, first column is for the mass, second column is for the radius, and third is for the force. Force is given by the product of m and mass and radius. Once you prepare this column, that is tabular column, and if you know the angular position of all the masses, easily you can find out the unbalanced mass by drawing this P force polygon. So to draw this force polygon, first you need to draw the space diagram, which already I have drawn, and tabular column. Now you need to draw the force polygon. First you draw O to A, which is equal to M1 into R1. O to A, M1 into R1. The magnitude of this line should be equal to this one. Then by taking alpha as the angle, draw A to B, and magnitude of this line should be second one, M2 into R2. Then take the beta from the horizontal line, and the magnitude should be equal to M3 into R3. Similarly, take gamma as the angle, and magnitude should be equal to M4 into R4. It will end here. Now to get the balance, for perfect balancing, it should be a closed force polygon. So from here you draw a line to join this origin. So the length of this line is going to be the balanced force, and the angle, this theta 4, is going to be the position for that unbalanced mass. Okay. So now from this, after joining this O to B, from this point to this scale, you have to take length of this one as should be equal to B into B. So to get this value, while drawing this force polygon, you have to take the proper scaling. Okay. For example, if I take 1:10 as the scaling factor, and if this is the 1.5 centimeter, then the magnitude will be 1.5 into 10, should be equal to B into B. From this you can get the value of unbalanced mass, that is B. And if you want to know the angle for that, you have to measure this angle in counterclockwise direction. You will get the value of theta B. So now we'll try to solve one simple problem by using this graphical method. So here is the statement. Three masses M1, M2 and M3 with the 10, 9 and 16 kg respectively revolve in the same plane with the radii 100, 125 and 50 mm. Angular position of masses M2 and M3 are 60 degree and 135 degree from M1. That means M1 is at 0 degree. Determine the position and magnitude of M4 at the radius 150 mm to balance the system. So here you are going to calculate M4, and he has given R4 also. So first you need to construct this tabular column. You know three masses, M4 is unknown, which you need to calculate. You know radii, write those radii in terms of meter and calculate the force. This is the force. After that you need to construct this force polygon, space diagram. M1 is on the horizontal plane, M2 is at 60 degree from M1 and M3 is at 135 degree from M1, and we don't know the mass M4 and we don't know the angle also. We need to calculate that. For that you need to construct the force polygon. So to construct that force polygon, first we need to select the proper scaling factor. So here I have taken scaling as 10:1. That means if it is 10 centimeter, then it will be 1 magnitude. That is, force will be 1. For 10 centimeter, it will be 1. Like that I have taken the scale. The first step is need to draw this OA parallel to this OM1. That is the reason why first you need to draw this space diagram. Magnitude of this line is 1 and angle is 0. Then for the second, that is to draw A to B, the magnitude should be second force, that is 1.125 and angle is 60 degree. Then for the third, the magnitude is 0.8 and angle is 135 degree. Now to complete this polygon, join this C to O. Okay, so length of this line is going to be equal to the force due to mass M4, that is force due to unbalanced mass. For that, you measure the length of this line. So for perfect balance, should be equal and opposite to the resultant force. So OC into scale, whatever the scaling factor you have taken, should be equal to 0.15 into M4. This 0.15 into M4 is in your tabular column. It should be equal to length of this line, because these are the lengths which are taken by the product of M into R, that is force. So now if I say that this is the force due to mass M4, that means the length of this line should be equal to 0.15 into M4. So 18.4 which I got, that is the length of this line, I got it as 18.4, and my scaling factor is 10:1, so I have to divide that 1 divided by 10, which should be equal to 0.15 into M4. From this we'll get the fourth mass M4 as 12.27 kg. And from this graph you can measure the angle in counterclockwise direction. So once you measure that angle, the angle will be 237 degree with respect to M1, that is counterclockwise direction. So we'll end the session today here itself. So in the next class we'll try to solve different problems, and you try to go through this graphical method, because most of the time we are going to use a graphical method only, because that analytical method will be a bit complicated. The only thing is you should know how to write this tabular column, and how to draw this space diagram, and this construction of force polygon, and you should know how to take the scaling factor, so that it will fit into a single page, your force polygon. Okay. So we'll end the session today here itself. If you have any doubt, you can leave the comment box. Okay. Thank you.